Cambridge AS Computer Science Chapter 10, Data Types and Structures, Linked List. We have to study now linked lists. What we did before, a linked list is one of the abstract data types. We did before stack and queue. The stack and the queue are among abstract data type. What is meant by abstract data type? It is a data type with some specific operations. The stack, you can only push an element on top. You can only remove or pop an element from the top. The queue is people in queue. In queue means they join the queue from the back, from the tail. They leave the queue from the front, from the head. That's why the queue is first in, first out. However, the stack is last in, first out. The stack reverses the order of data. The queue keeps the data in order to make it fair. Now we have to study another abstract data type called the linked list. Okay, it is a little bit more complicated than a stack and the queue, but you have to study it in the AS only in the form of diagrams. You only need to draw diagrams, but you need to understand this very, very well, because in the A2, if you are going to do the A2, you will have to write codes for this, or pseudocode or Python. So the bases are taught here in the AS. So a linear list such as an array. Okay, so if we are talking about an array, we are just mentioning here the array for comparison. In a linear list such as an array, the items are stored in consecutive locations. So in memory or in the array, you have item in location number 1, followed item in location number 2, 3, 4, 5, 6, consecutively, like this. This is not always the best. Another method is store an individual list of items in whatever location is available, and then link individual items in an ordered sequence using pointer. Ordered means, for example, items are listed in ascending order or in descending order. Let us always use, for example, ascending. Okay? Using pointers, let us study this diagram. Items in lines in red here are pointers. And see, they look complicated. We will make things easier and clearer. Okay, so this is a node. What is a node? Is the node will be programmed using a record. You already should know what a record is. Okay, so this node is a record. A record consists of, for example, here, two items. The data item and a pointer. What is that pointer? The pointer is an address. Okay, so for example, this is the start pointer. The start pointer points to cat, and cat points to dolphin, and dolphin points to elk, and elk points to fish, and fish is the last item in the list, so it points to 0, and 0 is called the null pointer. Why do I have to do this? This is just an illustration that you have a linked list. This is what a linked list should look like. This is a linked list with nodes. Every node has the data item and the pointer to the node after. Okay? It looks complicated, but however, it has benefits. There are many benefits of this. Okay? In the first place, you can sort them in order by adjusting pointers. As you can see, this will be called the start pointer, and it points to cat, and after cat, dolphin, and after dolphin, L. It looks like C followed by D, followed by E, followed by F. So it is in ascending order. Okay, what you have to know now is that a linked list consists of nodes. Every node consists of a data item and a pointer. Okay, the data item is some data, for example, text or so. The pointer is an address for the next element node in the record. Okay? An element of a list is called a node. This is a node, this is a node, this is a node. And when you create program for it, in pseudocode, for example, you will create a record or maybe a two-dimensional array. A node can consist of several data items. Here, the node consists of only one data item and a pointer. This is a pointer. Okay? The pointer is a variable that stores the address of the node it points to. Okay, this one is pointing to address 0. In this array, there is no address called 0. We call this the null pointer that points to nowhere. It indicates the end or the termination of the list. Okay? Okay. A pointer that does not point at anything is called a null pointer. It is usually represented by the phi variable. This is 0 or here phi. A variable that stores the address of the first element is called a start pointer. This is the start pointer. Okay, so the linked list use the following terms. Please know them. Node is an element of a list. Pointer is a variable that stores the address of the node it points to. Null pointer is a pointer that does not point at anything. Start pointer, this is the start pointer, is a variable that stores the address of the first element of a linked list. It looks like a chain. So if you want to read the list, you use the start pointer and see if it goes to what list, what node. And then after visiting that node, you see how it points to the node after, okay? The data value in the node represent the key. This is the key field. And probably I don't like duplicates. Okay, so a key field or primary key has no duplicate. ماشي? These are likely to be many data items associated with each node. The arrow represents the pointer. Look at this. This is a neater diagram for a linked list. The linked list diagram does not show at which address a node is stored. So the diagram does not give the value of a pointer, only where it conceptually links to. So, for example, this is a better diagram for a linked list. This is the start pointer, and it points, for example, to some address that is not written here. However, that address stores node B. So here you have B. And node B points to the next node. So it points to D. Okay? And D points to the next node. That's node L. And L being the last node in the linked list, it points to phi, which means nowhere. Okay? Okay. So features of a linked list. Probably that was a question in the exam. Each node contains data and a pointer to the next node. There is a pointer to the start of the list called start pointer. Last node has a null pointer. This phi or this is the null pointer. Data may be added or removed. We need to learn how to add data and remove at the start or in the middle or at the end. And this will be done by manipulating pointers. For example, to put a node between B and D, probably is going to be C. So you let B point to C and C points to D. We will show this by diagrams. You only need to do conceptual diagrams here in the AS. But understand it very well because in the A2, you will need to write program codes for them. Okay? Data may be added or removed by manipulating pointers. Okay, nodes are traversed in a specific scene. What is meant by traverse? You go through them all. So you start with the start node and you follow to node B. B follows you, forwards you to node D, D forwards you to L, and L is the end. It points to nowhere. It points to the null pointer. Then you have to stop. يبقى nodes are traversed in a specific sequence. Unused nodes, this is something new. You have what is called free list. You have unused nodes. We will look at this later. We will talk about unused. This is the free list. So this is the linked list, and there is another something called free list. This is the free list. Okay. So here I have what is called free list. We will be studying the free list very soon, because you need to understand it conceptually also. And in the A2, you will write code. Unused nodes, these are unused nodes. As you can see, they have no data in them. Are stored in a free list. This is a free list. A free list pointer, this is the free list pointer, points to the first element in the free list. Okay, so you have here the linked list. This is what we are studying. This is what is called the free list. You have to understand it very well. Okay, adding a node at the start of the list. If you want to add a node at the start of the list, you have here the start pointer points at B, and B points to D, points to L, that like this. You want to put something before the B. B is the first element in the linked list. For example, you want to store A, and alphabetically, A has to go before B. Okay, so what will happen? You have to learn it by description, only description. Okay, what will happen? You will take one element from the free list. You take one empty element from the free list. Okay, and you store in it the value A. Okay, so you take one of these from the free list and put in it A. Okay, okay. The start pointer used to point to B. However, now you make the start pointer points to A, and A points to B, and now the sequence become A followed by B, then D, then L, then the end. Okay, you need to study it by drawing. You only need to do drawings. It's very simple for the AS. Okay, so a new node A is inserted at the beginning of the list. The content of the start pointer is copied to the new node pointer. So the start pointer is pointing at B. You make it here. You make B points to at whatever was the start pointer pointed to. ماشي? And the start pointer now, ماشي, is set to point to the new node that stores A. Okay, so this is the diagram of storing a node at the beginning of the list. You only need to learn it by diagrams. Okay, okay. Adding a node at the end of the list. Okay, again, you take one empty node from the free list and put in it the value, for example, is gonna be P. Okay, and you want to, alphabetically, P should follow the L. And the L is the last element in the list. Okay, okay. So L used to point to phi, which means the end. Now you will make L point to the node P, and P will point to phi, because now P is the new end of the list. Okay, so for example, a new node P is to be inserted at the end of the list. The pointer field of node L points to the new node P. So you'll make L used to point to phi, used to point to nowhere. You will make it point to P. The pointer field of the new P contains the null pointer. You will put here the null pointer because P now is the new end. So C is all about manipulating pointers. This somehow could be more efficient. Somehow, under certain situations, would be more efficient. For example, when you are dealing with a very long list and everything is sorted and you want to add something in the middle, it would be better to change 2 pointers. I know it is more complex to understand, however, it's in the computer science. Adding a new node between existing nodes. Okay, I would like to add node C. So alphabetically, C has to be between B and D. Okay, so it is the same concept. You take one node from the free list. You take one node from the free list and store in it the value C. Okay, and then you decide that C should be between B and D. B used to point at D. Now B will point to C and C will point to D. Okay, so adding a node between existing nodes. Sometimes the nodes are linked together in the order of the key field, ascending order, to produce an ordered linked list. Okay, this means a new node might need to be inserted or deleted from between two existing nodes. Okay, I would like to keep them ascending. This is an ordered linked list. To insert a new node C between existing nodes B and D, we copy the pointer field of node B into the pointer field. So B, the pointer here, that dotted pointer, the value of it will be copied into here. So B used to point at D, now C is pointing at D. We change the pointer field of B to point to the new node C. Okay, so it is all about changing pointer. Okay, deleting the now we have studied examples of adding. Let us study examples of deleting. Deleting the first node. To delete the first node in the list, we copy. So simply the start pointer used to point at B and B will points at D. We will make the start pointer skip the B and points directly to D. Now B does not belong to the linked list. However, you would like to make B join the free list so that you can reuse it in the future. We don't have to deal with this. At the moment, we don't have to deal with this. Even the A2, you don't have to go to that much details. So you would like to delete the B, start pointer used to point at B and B points at D, make the start pointer points at D and skip the B. However, actually B will be assigned to the free list. Okay, now you know what the free list is. Deleting the last node. Okay, L used to point at phi. Now you want to delete the L. D used to point at L and L points at phi. You make D points at phi, phi means null, and then L does not exist. Is not among the list. However, L, you may need to add it to the free list. But this is not very essential right now. Deleting a node between two existing nodes. So B points to D and D points to L. You would like to delete the D, just skip it. Make B points directly to L. So we copy the pointer here to delete the node D, within the list. We copy the pointer field of the node. So this used to point to L. Okay, that is point D. We copy this address. We copy the address this and put it in the node before. So the node used to point at D now will point at L, skipping the D, the B, okay, the D. Okay? Why do we have to do all this? Because it is better. Advantages of using linked list. There are some advantages of using linked list. And real application data would consist of much more than a key field and one data item. This is why linked lists are preferable to linear list, that is the array. When list element need to ordering. When list elements need reordering, only pointers need changing in a linked list. Like this example, we will look at example now of arranging. Yeah, that was the unordered linked list, and this is the ordered linked list. It is better and easier to sort by changing pointers. Okay? Okay? In a linear list array, all data items will need to be moved. Pointers determine the order of data, and only the pointers need to be changed when data changes. It is easier to add and delete data and maintain the correct sequence in a linked list. Okay? So when list elements need reordering, only pointers need a change. Disadvantage of using linked list. Using linked list save time. However, we need more storage space for pointing fields. Okay? We need more storage space. Store the pointers. We need to store pointer as well as data. Okay? So we need to store pointers as well as there. So more storage space for the pointer field. Also more complex to set up and implement. It looks like you have to study it and it takes more effort. Okay? Okay. Storing a linked list in an array. Let us practice with the linked list and store it in an array and see how pointers and things. We can store the linked list in an array of records. We need a record. You already know what a record is because you studied record. A record, for example, a record node has two elements, name and pointer. The name will store the data in the linked list. The pointer will point to the next element in the linked list. Okay? Or maybe two arrays, or maybe two-dimensional array. There are so many ways of storing the linked list. Okay, we can store the linked list in an array of records. One record represents a node and consists of the data and a pointer. When a node is inserted or deleted, only the pointers need to change. A pointer value in the array is the array index of the node pointed to. The pointer is actually an array index somewhere in the array. Now we have to talk about unused nodes. Unused nodes will be in the free list. We already did that. Unused nodes need to be easy to find. A suitable technique is to link the unused nodes to form another link called the free list. So we have the original linked list that contains the data. We have another list called the free list. Joining all unused nodes together so that we can reuse them. Okay? Initially, before storing anything in the linked list, everything will be in the free list. Before we store anything. Okay? Okay. So, when an array of nodes is first initialized. So this is the step to create a new empty list. Okay, so this is initialize or create a new empty list. When an array of nodes is first initialized to work as a linked list, the linked list will be empty. So you will have nothing in the linked list. You will have everything in the free list. Okay? So the start pointer will point to null. The start pointer will be the null pointer. All nodes needed to be linked to form a free list. All the nodes will be in the free list. Below is an example of an implementation of an empty linked list before any data is inserted. So the start pointer will point to -1, and that -1 will be the phi or the null or the terminator. There is nothing in the linked list. However, the start of the free list pointer will point to 0. 0 is the first element in the array. And the first element in the free list points to the one next. So this is the first element in the free list. As you can see, they are all chained. So the free list starts with 0, and this points to 1, and the next points to 2, and the next points to 3, and the next points to 4, point to 5, point to 6, and 6 is the last element in the free list. It points to -1. This is the end of the free list. Okay, so here we have two arrays. Array called data, array called pointer. This will store the data, this will store the pointer. The start pointer points to -1 because it's all empty. The free list will start to the first element in the array, and every element will point to the element after. Okay, let us go into examples, and maybe these are exam examples, and that's it. Let us go to few examples, and then we practice past paper. And these examples are from the past paper. Okay, let us study this example. The linked list abstract data type is to be implemented as a linked list of nodes. Each node consists of a data and a pointer to the next node. Using pseudocode, a record type node is declared as follows. So this is a record. So you define a record called the name. That record contains two elements, a name and a pointer. So you define a record called the node. And that record has two elements, name and a pointer. Name will be of data type string to store the data. Pointer will be of data type integer because it will be the pointer that points to the node after. Then we declare an array called list 1 to 10 of 10 elements. Each element of them is of type node. So the statement declare list array 1 to 10 of node. This reserve space for 10 nodes in the array list. Okay. The created list operation will link all nodes. So you have to make nodes, you have to make the free list. You have to make the free list. The create list operation links all nodes and in the free list and initializes the 3 pointer that need to be used. Okay. So this is the element, and it points, this is element number 1 and points at 2, and here like this. Okay. So pointers. So let us assume this is the free list pointer. It will point at 0. This is the point, the start pointer will point at 0. This is the free list pointer will point at 1, and 1 will point at 2, 2 will point at 3, 3 will point at 4, until the last element will point at 0. Let us go to a better example. This example is copied from very recent exams. The following diagram represents an abstract data type. We have this A is the start pointer. Maybe the exam will ask you, what is the meaning of A? You should say that A will be the start pointer. A will point at dolphin, dolphin will point at cat, cat will point at fish, fish will point at elk, and B, the exam will ask you, what is the meaning of B? You will say B will be the null pointer, okay? And the list initially is unsorted. So this type of abstract data type is a linked list. The technical term for the item labeled A in the diagram is the start pointer. The technical term for the item labeled B in the diagram is the null pointer, which means that there are no further nodes at the list. Null pointer means there are no further nodes in the list. The exam then was asking you to draw a diagram that shows the pointers after rearranging and putting them in order. The diagram shows, okay, the diagram shows okay, the next diagram shows the abstract data type after data has been sorted in alphabetic order. So that was supposed to be your answer. So you want them in order, and you know that C, cat, will follow D, dolphin, and then E, elk, and then F, fish. So you make the start pointer point to the first element, that is the cat. And you make the cat points to the element that is the dolphin. And dolphin will point to the elk. And elk will point to the fish. And fish, being the last element in the list, will point to 0 or null or nowhere. Okay, that was an example. Okay, let us study. Oh, we are about to finish. We will go and see examples in the past paper. The following diagram represents an abstract data type for a linked list. So A followed by C followed by D and E, this is the end. The free list pointer, okay, this is the free list pointer, and all elements will point to the one next in the free list pointer. A node contain data value B is to be added to the list. Okay, a node containing value B is added to the list in alphabetic sequence. Okay, so a node containing data value B is to be added to the linked list in alphabetic sequence. So you want to add B. Probably you need to add B between A and C to keep the list in alphabetic sequence. Okay, so what are the steps? Search for a free node. Okay, take one from the free list node. Search for the correct insertion point. Shall it be before A? Shall it be after A? Shall it be between A and C? Between C and D? Okay, search for the correct insertion point. The correct insertion point will be between A and C. Assign the data value B to the first node in the free list. Okay, this is the free list. This is the first element in the free list. Store in it B. That is the node pointed to by the start pointer. So the start pointer of the free list is pointing to this. Put this B in this B. Pointer from A will be changed to point to the node containing B. instead of C. So A, instead of pointing to C, will now point to this. Pointer of B will change to point to the node containing the C. This used to point to the next element in the free list. It will point to this. The start pointer move to point to the next. The start pointer used to look pointed this. This is no longer free. The start pointer will point to the element after. Okay. The linked list may be implemented using variables and arrays. And a one-dimensional array to store the data and a second one-dimensional array to store the pointer. Something like this. You will need one-dimensional array like this to store the data and another one-dimensional array to store the pointer. Okay, so it will be something like this. Or, okay, and you will have an integer variable to hold the start pointer and an integer variable to store the next free pointer. These are the 2 pointers for the start of the list pointer, and this is the free list pointer. Alternatively, may create a record. Alternatively, you may create a record like this, and you create an array of records. Define a record type containing data element and a pointer and declare an array one dimension of this type and also variable for the start pointer and a variable for the next free point. These are answers to questions in the past paper, in recent past paper. I think I told everything now about the linked list. Let us go to exam questions. Please go to page 256 in the classified. This example is from 22 November, paper 21. The following diagram shows an abstract data type representation of an order linked list. The data item stored in each node is a single character, C or J or L, and this is the null pointer. The data will be accessed in alphabetical order. The symbol phi represents a null pointer, and this will be the start pointer. Nodes with A and K are added, so A should be before the C to keep it in ascending order. Okay? And K should be after the J. Nodes with J and L are deleted. After the changes, the data item will still need to be accessed in alphabetical order. Complete the diagram to show the new state of the linked list. So J and L will not be among the list. C, before it we will put the A, after it we will put the K. So you have to draw something like this. This is the mark scheme. The star pointer will point to A will point to C will point to K will point to phi. These will be nowhere. Actually, J and K should be added to the free list, but this is too complex for us in the AS to consider. Next, they ask you about the advantages of using a linked list and the disadvantages of make using the linked list. Here you are. So the advantage of using linked list is that pointers determine the order of data. Only the pointers need to be changed when data is changed. Easier to add, delete data to maintain correct sequence in a linked list. Okay. It has In an array, you have to do bubble sort. Disadvantages. Disadvantages: need more pointers as well as data, need to store pointers as well as data, more complex to set up. A program will store data using a linked list like the one shown in part A. Explain how the linked list can be implemented. First, you define a record type, or you use two arrays, and then you create one-dimensional array of that record type. And then you declare variables. I think this is mentioned in my notes here. So, declare a variable for start pointer, define appropriate null pointer, declare an integer variable for the free list pointer. You create the routine to add, delete, and search. So a program will store data using a linked list like the one shown. Explain how the linked list can be implemented. You may declare two arrays, one for the data or one for the pointer, or alternatively, define a record type with the field for the data pointer and one-dimensional array of that record type. So instead of two arrays, you may create a record and one array of that record type. Okay, so 1 and 2 could be replaced by 1 and 2 and 3. And then element from the same index represent one node. These three lines would be replaced by these three lines in case you decide to create a record. The mark scheme somehow is confusing. But for either ways, you have to create a start pointer. You have to define the null pointer. You have to create a free list pointer. You have to create routines to add, delete, and search for items. Okay? Okay, that's it. This is all the questions we have. Okay, this one is left from 15 June, very old one. Okay, this one, that one about cat already included in my notes. That one also already included on my notes. And those one before about stack and queue. Okay, that's it for linked list. We will look for new examples in 23 November or 23 June.